In this recording, we're going to look at measures of dispersion. Dispersion means spread out. So I'd like you to look at each of these four figures. And I'm going to tell you that the mean, or the average, for all four data sets is 3. Maybe you want to imagine that each one of these is a different class, and that the dots represent scores on an exam, like an AP exam, where you get a grade or a score between 1 and 5. So if you think about this first class, or this first figure, the mean represents a typical student in the class. There's not many people on the outsides. It's kind of like the bell curve. Okay? Figure 2 is basically the inverse of that. You have some real people out at the extremes. 3 doesn't represent the average student, the typical student, very much. Figure 3, again, you have some kind of mediocre 2s here. You got some stronger 4s, not many 3s. Again, that's a different class than the first one. And finally, figure 4, you have some handful of really strong students. The majority of the students are 2s. Again, quite different. So if all we know is the average, the mean, we really don't know that much about the data set. However, we don't want to hear all the numbers. Our eyes glaze over if we were to read off every single student's score. So we do need some quick summary statistics to be able to discuss particular data sets. In addition to knowing the mean, we'd like to know maybe how spread out the data are. So for example, we might be interested in knowing the range. Okay? Let's look at these two classes, these two sets of data. In each case, the mean is both 6. It's 6 in each case. But the classes are quite different. If I asked you to find the range of the data, you'd simply take the largest number, 10, subtract the smallest, 2, and you'd get 8. So, unlike domain and range of a data set is the smallest subtracted from the largest. It's a single number. The range of a function is the set of y values. So I don't want you to be confused. We're using the same word there. Again, we're going to get a definition of this in a moment. Next, I want you to look at the fact that the mean of each set is the same. The mean in both cases, the mean is 6. The way we're going to represent mean is with a X bar, like this. X with a line over the top. So it's our symbol for mean. In each case, that's 6. So we don't have any way to distinguish between these two sets if all we know is the mean is 6 and the range is 8. I want you to consider another example. Let's look at this test scores for two students, Heidi and Eric. Okay? I want you to use your calculator to find the mean for Heidi and the mean for Eric. Then I want you to find the range for Heidi and the range for Eric, and play the recording when you've got both those values. Okay, so hopefully you figured out that the mean for Heidi is 90 and the range is 24. The mean for Eric is pretty similar, 92, but the range is only half as much. So if you had these two sets of summary statistics without knowing their actual scores, you might say, well, they're pretty similar students. They have both averages in the low 90s, but Heidi is twice as spread out because her range is double. But now I want you to look carefully at those numbers. Those numbers are exactly the same. She just had one low score compared to Eric's. So again, range is not the best tool to measure how spread out the data are, because it's very affected by an outlier, a low number like this, an extreme value. Okay? So let's formalize this a little bit. Why don't you grab some notebook paper and write down some definitions of range. This is the difference between the largest element and the smallest element. Play the recording when you're ready. Next, I want to introduce interquartile range. So that's the difference between the first and the third quartiles. The reason we like the interquartile range is it's resistant to outliers. It doesn't matter so much if you have a low score like Heidi did. Let's go back to Heidi and Eric. Okay, if I'm interested in knowing the interquartile range, if you remember from your Algebra 1 days, we find the median, just the middle of those, so that would be between 91 and 92, it would be 91.5. Then to find the first quartile, we're basically splitting up the data into quarters, like a football game, or quarters like a school year. Okay? So the first quartile is the middle number of the first half of the data, so 88. In both cases, 88. The third quartile is the middle or median of the second half of the data, so in both cases, 95. So the interquartile range, another way to say interquartile range is IQR, so it's abbreviation. Interquartile range in each case is 95 minus 88. So our IQR for both is just 95 minus 88 is 7. So in both cases, we would say, you know what, they're pretty much spread out the same. The difference between their quartiles is the same. Okay. So I'd like you to practice that. I'd like you to take these 6 IQ scores. I'd like you to figure out the range of the data. Now notice the data is not in order. Play the recording when you've got the range figured out. Okay, so hopefully you figured out the range was 130, which is the maximum, minus 118, which is the minimum, is 12. Now if I'm interested in the interquartile range, I'm going to need to set these data up in order. Okay. Okay. I could put these in order, and then figure out the median, figure out the first quartile and the third quartile, and subtract. Not too hard. But we're going to look at it a different way. We're going to look at how to do this with the calculator. So grab your calculator. If you don't have a calculator, you can just watch along. But if you have a calculator, you should use it. We're going to go to Stat. We're going to edit, just like we did when we put in our data for our regressions. We're going to clear out data that is already in there. Hit Clear, Enter, and move your cursor on top of the list 1. Hit Clear, Enter. Just like we did before, I want you to enter those 6 IQ scores. Make sure you didn't make any typos. When you're ready, play the recording. Now we're going to hit Stat and Calc. Now we're not going to do any regressions, and we only have one variable. You're only always going to use one variable stats. You're never going to use 2 variable stats in this course. So we're going to go to one variable stats. Hopefully your calculator has the wizard, the stat wizard on. Our list is in L1. We do not have a frequency list, so we just go to calculate. Okay, you're going to notice some information here. This x bar is the mean. That's a sigma, it's the sum of all the scores. So if I took that number and divided it by this number, the n is the number of values, I should get 125. We'll learn about these other figures. We'll never use the sum of the squares. We'll learn about these other figures later today. I want you to scroll down, and you'll have some more summary statistics. You should be able to recognize the meaning of each one of those. And so to find the interquartile range, we simply need to take the Q3, the third quartile, 128, and subtract the Q1, the first quartile, 122. So Q3 minus Q1 turns out to be 6. And that's the work right here that we would show on our paper. Thanks for watching.